Good morning, everybody. I'm S. Mamta, lecturer in Department of EIE. I'm going to teach you instrumentation in process industry subject. In this, today we'll discuss Unit 3 Iron and Steel Plant Instrumentation. We have discussed all the topics, that is what is steel, layout of iron and steel, various units in iron and steel, raw materials in iron and steel plant. It's a how iron and steel will be formed in BF and BOF process, continuous casting, types of steel, different furnaces used in iron and steel plant, blast furnace, its layout and manufacture, and how the steel will be, molten iron will be formed, and what are the reactions takes place in the iron and blast furnace. Next, this is the layout of block. This is the block indicating the blast furnace. Next, we have discussed about the basic oxygen furnace and its description, explanation and different parts, procedure, how to take the charge inside and how to remove the molten steel outside, and what are the reactions taking place in basic oxygen furnace. Next, we have discussed electric arc furnace, whatever the scrap that was available in the iron and steel plant, that will be sent to the electric arc furnace. There it was converted into the molten steel, that we have discussed in the last classes. Today we will discuss about what are different parameters that has to be discussed in the that has to be measured in the iron and steel plant. Temperature is the main parameter that to be measured and monitored in the iron and steel plant. Mainly, we will measure the temperature by using pyrometers. Pyrometer, it's a non-contacting device. We have a lot of temperature devices like thermocouples, thermistors, RTDs and thermopiles. So whatever the devices, those are in contact with the body whose temperature that we want to measure. But when coming to the pyrometer, it is a non-contacting device that intercepts and measures thermal radiation, a process known as pyrometry. This device can be used to determine the temperature of an object's surface. Wherever temperature of an object's surface has to be measured, where the particular device is not in contact with the body whose temperature we want to measure. That's why it is called as the non-contacting device. Pyrometer is a non-contacting device. Why? Because it depends on the measurement of thermal radiation emitted by the body. It's not touching the body and measuring its temperature. It will measure whatever the thermal radiation emitted by the body. It will capture the thermal radiation and again it will measure that radiation. That's why it is called as the non-contacting device. The word pyrometer comes from the Greek word for fire, that is pyro. That is Greek word pyro, and meter means measure. So by combining these two words, we can call it as the pyrometer. Pyrometer was originally coined to denote a device capable of measuring temperature of objects above incandescence, that is objects bright to the human eye. That's about the pyrometer introduction. Generally, it's a non-contacting device. It will measure the thermal radiation. That is the main concept in the pyrometer. What is the principle of the pyrometer? Pyrometer has an optical system and a detector. The main principle and operation of the pyrometer is it will be having a optical system and a detector. The optical system focuses the thermal radiation onto the detector. The output signal of the detector is related to the thermal radiation or irradiance of the target object through the Stephen-Boltzmann's law. The constant of proportionality sigma, called the Stephen-Boltzmann's constant, and the emissivity of the object. So the formula is whatever the thermal radiation energy, it is equals to emissivity plus emissivity, the product of emissivity, Stephen-Boltzmann's constant, and temperature. This output is used to interfere an object's temperature. Thus, there is no need for direct contact between the pyrometer and the object, as there is with thermocouple and resistant temperature detector. Like resistance and thermometer, thermocouple, and resistant temperature detectors, like those devices, there is no need to be in contact with the object. Here we are measuring the thermal radiation, or it is dependent on the emissivity of the object. Here this is showing the working of the pyrometer. Pyrometer or radiation thermometer is a non-contact instrument that detects an object's surface temperature by measuring the temperature of the electromagnetic radiation emitted from the object. Here we are measuring the radiation thermometer is a non-contact instrument that detects an object's surface temperature by measuring the temperature of the electromagnetic radiation emitted from the object. The wavelength of thermal radiation ranges from 0.1 to 100 micrometer from the deep ultraviolet across the visible spectrum to the middle of the infrared region. Generally, whatever the thermal radiation emitted by the body, that will be in the range of 0.1 to 100 micrometer from the deep ultraviolet across the visible spectrum to the middle of the infrared region. That is the wavelength of thermal radiation emitted by the hot bodies that can be measured by the pyrometers. The following are some of the most commonly and widely used pyrometers. Those are optical pyrometers, radiation pyrometers, digital pyrometers, and infrared pyrometers. Mostly we will go for optical pyrometers and IR pyrometers, or radiation pyrometers, and converting them into digital pyrometers. Optical pyrometer work on the basic principle of using the human eye to match the brightness of the hot object to the brightness of the calibrated lamp filament. Generally, this optical pyrometer, it also called as disappearing filament type of pyrometer. Optical pyrometer, it can also be called as disappearing filament type pyrometer. The optical system contains filters that restricts the wavelength sensitivity of the devices to a narrow wavelength band around 0.65 to 0.66 microns, the red region of the visible spectrum. It will allow only certain wavelength of the total emitted radiation wavelength. Other filters reduce the intensity so that one instrument can have a relative wide temperature range capability. Needless to say, by restricting the wavelength response of the device to the red region of the visible, it can only be used to measure objects that are hot enough to be incandescent or glowing. This limits the lower end of the temperature measurement range of these devices to about 700 degrees centigrade. Some experimental devices have been built using light amplifiers to extend the range downwards, but the devices become quite cumbersome, fragile, and expensive. Modern radiation thermometers provide the capability to measure within and below the range of the optical pyrometer with equal or better measurement precision, plus faster time response, precise emissivity correction capability, better calibration stability, enhanced ruggedness, and relatively modest cost. Relatively modest cost. This is about working of a optical pyrometer. Generally, by using the filters, we will filter out the particular wavelengths. That wavelength intensity will be calculated, that will be proportional to the whatever the temperature that was that we want to measure. But here, by limiting to the wavelength, the particular lower temperature of the device will be limited. That means it limits up to 700 degrees centigrade. By using light amplifiers to extend the range downwards, but the devices become quite cumbersome, fragile, and expensive. This is about the working of optical pyrometer. This is the structure of the optical pyrometer. So this is the structure of optical pyrometer. Here our eyepiece will be lying here, and whatever the heat whose temperature that we want to measure, that heated source will be here. Next, objective lens, which will focus the total heat onto this particular screen. Next, absorption screen, and whatever the filter. Next, eyepiece. Here we will be having a rheostat, PMMC meter, and battery. This will allow some current to the filament. What happens here means, this is a bulb. Whenever this current flowing through the bulb or heat emitted by this light intensity emitted by this bulb is more than the radiation emitted by the heated surface, this filament will appear brighter when seeing from this eyepiece side. When watching from this eyepiece side, when the intensity of this particular bulb brightness will be more compared to the radiation intensity, the bulb filament will be viewed very bright. When we increase or decrease the current through the rheostat or current through the filament, the brightness will be lower. Then if the heated surface will be more heated, from the heated surface, if we get the radiation more, the filament, through the filament the radiation is less, then the particular filament will be appearing dull. That the particular when the rheostat current is varied such that when the whatever the radiance that is coming coming from the source and from through the filament, both are equal, at that situation, when we are watching from the eyepiece side, the filament does not appear. That's why it is called as the disappear filament type of optical filter. When this particular line is when the current flowing through this particular rheostat is equivalent to the will give the brightness of the filament which is equivalent to the whatever radiation emitted by the heated source. At that time, if we watch from the eye side, then no filament will be appearing. Like that we can calculate the what is the temperature by counting the current flowing through the PMMC meter. That current will be proportional to the whatever the temperature that will be that are from heated source. This is called as the disappear filament type. Once you go through this particular slide, what happens means, here this is eyepiece, this is light bulb, and this is absorption screen, and here from temperature source. Here from the temperature source the heat radiation will be appearing, and through battery and rheostat, by adjusting battery and rheostat, we are sending current through this particular lamp. Whenever current through the lamp will give the brightness to the filament, that brightness is equivalent to the whatever radiation coming from the temperature source. Then if those two are equal from the eyepiece side, if the observer observes, then there will be no filament will be appearing. At that condition, the current through the rheostat will give the temperature reading. That's about the disappear filament type of optical pyrometer principle. Here, if the brightness of the filament is more compared to the radiation emitted by the particular temperature source, if the filament is less, brightness of the filament is less, then the radiation emitted by the filament is low compared to the heated body. This is about the optical pyrometer. What are the advantages of the optical pyrometer? It is flexible, portable, convenient to use, lightweight, can monitor movable objects, non-contact type, and accurate. Next, disadvantage: expensive, human errors, not useful for measuring temperature of clear gas. At high temperature, filament erodes frequently. Disadvantage: expensive, human errors, not useful for measuring temperature or clear gas. At high temperature, filament erodes frequently. These are disadvantages of the optical pyrometer. So we have discussed about the optical pyrometers. Optical pyrometers, those will depend on the generally pyrometer itself depend on the principle of the Stephen Boltzmann emissivity or thermal radiation principle. J equals to epsilon sigma T power 4. That is the principle of our pyrometers. Then optical pyrometer, general pyrometer will be emitted pyrometer or radiation thermometer that will emit the radiation in the UV electromagnetic radiation region. Generally it will emit the thermal radiation in the wavelength of 0.1 to 100 micrometer, that is from deep ultraviolet region to the middle of the infrared region. Types, coming to the types of the pyrometer: optical pyrometer, radiation pyrometer, digital pyrometer, infrared. We have seen the optical pyrometer where we have discussed this is disappearing filament type of optical pyrometer, and next we have discussed that optical pyrometer diagram. We have discussed the working of disappear filament type of optical pyrometer. Next, advantages and disadvantages that we have discussed, because as we are watching the brightness of the filament, we require human eye. That's why human errors may occur in the particular optical pyrometer. Next, radiation pyrometer. So this is the structure of the radiation pyrometer. Here is the radiation pyrometer device diagram. Here it is also depend on the Stephen Boltzmann constant and thermal radiation principle. Radiation diagram. Radiation pyrometer is also dependent on the Stephen Boltzmann thermal radiation principle. Here not here it is also consisting of a optical system and a detecting system, but here also what we are using, we are not having any human eye to watch the filament like that. Here what we are doing is, whatever the hot body is there, from the hot body we will be getting the thermal radiation. That thermal radiation is focused onto the whatever the, by using lenses and mirrors, that thermal radiation will be focused onto the thermal detectors. Those are nothing but the thermistors or photomultipliers tubes. Through that the temperature will be measured, and the temperature will be calibrated in terms of the whatever the temperature that will be, whatever the temperature that will be emitted by the hot body. These thermistors and photomultiplier tubes, they cannot withstand to the whatever the highest temperature ranges. Pyrometers generally it is around 1700 degree centigrade temperature. So that much temperature these thermocouples, thermistors or photomultiplier tubes cannot withstand if they are in contact with that. So in order to avoid that, the thermal radiation emitted by the heat hot body is taken into purpose, and that thermal radiation by using optical system, the radiation by using optical system, it is adjusted by lenses and mirrors and focused onto a detector. That's also again thermal detector, that is nothing but thermistor, photomultiplier. During this process the maximum temperature has to be minimized, that will be measured and that will be calibrated in terms of the higher temperature readings. So here we'll be having a, though the latter is known for faster detection of fast moving objects, the former may be used for small scale application. Thus the heat energy is converted into its corresponding electrical signals by the detector, and it is sent to the output temperature display device. This is the working of the radiation pyrometers. Here block diagram of radiation pyrometers. We got a hot object and it will be passed through the lens, and that lens it will be passed through the mirrors, and through the mirrors it will be passed to the detectors. When this detector, it is nothing but it is a temperature detector. It's a temperature detector. This temperature detector, it will measure the whatever temperature that was given by the thermal radiation emitted by the hot body. These temperature detectors are nothing but the thermistors or photomultiplier tubes. These photomultiplier tubes or thermistors, they will directly display the temperature range, temperature value directly displayed by these particular photo detectors. This is radiation type of pyrometers. Advantages: ability to measure high temperature, no need for contact, fast response speed, high output, moderate cost. Disadvantages: emissivity errors are introduced, errors due to absorption of radiation by carbon dioxide, water or other apparently transparent gases. Errors may be introduced, or errors due to the absorption of radiation or carbon dioxide, water may be occurred in this particular type of radiation type of pyrometers. What are the common detectors that we are using? Then those are photomultiplier tubes or thermistors. Those are nothing but thermopiles, photocells, metal bolometers and thermistors. This is about the radiation pyrometers. Next, infrared pyrometers. What are infrared pyrometers? Whatever the radiation emitted by the hot body, that may be in the infrared region, that by measuring that infrared radiation intensity, we can evaluate the temperature of the human body. Here it is the target, and here it is the atmosphere, and here we will be having detector. That detector output will be displayed and interfaced. This is the So this is the small device. This device is showing the IR pyrometer. IR pyrometer. The detector converts IR received into electrical signals, which are then emitted as temperature values by electronic system. Infrared pyrometers. The target emits infrared radiation according to its temperature that will be measured by the detector. Infrared pyrometers advantages: high temperature measurement greater than 1300 degrees centigrade, wide range, fast response, measuring moving objects which are difficult to access, high voltage parts, great measurement distance. For such situations we can use IR pyrometers. Generally, what are the IR detectors that can be used means, here we can use different photovoltaic type of IR detectors, thermal type of thermopile type IR detectors. We have a lot of IR detectors. These are some type of IR detectors that can be used in the IR pyrometers. Next, until now we have discussed about IR detectors, IR pyrometers, photoelectric pyrometers, radiation pyrometers. Next, level measurement. So here we will be having different molten steel. In the steel industry, we have to monitor what is the molten steel level in the blast furnace or basic oxygen furnace, or in the continuous casting also. In the continuous casting unit we have to frequently measure the steel level. So in the steel level measurement using eddy current transducer. Eddy current level meter that is ECLM is the most advanced system for measuring the molten metal level in mold with the high precision and quick response time. Mold means the container which holds the molten steel. It is nothing but the mold being applied for the mold level control system. ECLM contributes to stable operation as well as cast products qualities by minimizing the fluctuations of molten metal level. Features: high precision of mold level measurement with no affection of mold flux, quick response time in detecting mold level fluctuation, broad measurement range, optional function to cancel out outer disturbances such as EMS, EMBR, magnetic field, easy installation for any type of mold shape, safe and easy operation. These are the features. Next, here we will be having a sensor, and this is the mold, and this is whatever the container that we have, that may be electric arc furnace or basic oxygen furnace, or it's a continuous casting machine, whatever it may be. Here mold oscillations will be there. The sensor output, it is given to ECLM amplifier. That ECLM amplifier, that is eddy current level monitoring unit, that will be given, the output signal is given to mold level controller, that will be given to servo amplifier, that will be given to actuator, which will rotate this particular control valve. Actuate will move the control valve. Inside the ECLM sensor, two types of coils are embedded. A primary magnetic field, electromagnetic field generated by high frequency current running in the exciting coil. Coil P produces the eddy current on molten metal surface. The detecting coil picks up the strength of induced eddy current, which is a function of distance between the sensor and meniscus. The value measured by the detecting coil is fed to the amplifier, and the processor for outputting the mode level signal to mode level control system. Here what is happening in the level control system is, whatever the primary sensor, here we will be having a primary sensor which will be connected to a magnetic field, or it's a alternating voltage will be connected to this with some frequency, so that current will be flowing through this, magnetic field will be created through this, and eddy currents will be produced between the coil and the meniscus of the molten metal. These eddy currents will be detected by the secondary winding or detector winding. Because of that eddy currents that will be flow through the whatever the amplifier unit, this amplifier unit will give a signal to the signal processing amplifier. That signal processing amplifier will give a level signal to the mode level controller. This level controller will move the actuator, or it will move the servo motor, and it will give a signal to the control valve, so that the molten steel level can be increased or decreased, the input flow level can be increased or decreased. That will happen in the electrical eddy current level monitor. So this is about the today's class. We have discussed about the lot of parameters in today's class. What are those? First, temperature measurement. Temperature measurement of molten steel. What is temperature measurement? Temperature generally measured by using thermometers, thermocouples or arteries, but high temperatures they will measure with the pyrometers. Pyrometer word, it's a non-contacting device. It intercepts with the and measures the thermal radiation, a process known as pyrometry. This device can be used to determine the temperature of an object's surface. The word pyrometer comes from the Greek word for fire, pyuro, and meter, meaning to measure. Pyrometer was originally coined to denote a device capable of measuring temperature of objects above incandescent. Principle of operation of pyrometers. It will depend on the Stephen Boltzmann's constant and the emissivity of. It will depend on the epsilon sigma T power 4. Working. Pyrometer or radiation thermometer is a non-contact instrument that detects an object's surface temperature by measuring the temperature of the electromagnetic radiation emitted from the object. The wavelength of thermal radiation ranges from 0.1 to 100 micrometer from the deep ultraviolet across the visible spectrum to the middle of the infrared region. Generally it is dependent on optical pyrometer. It will dependent on the disappearing filament type of optical pyrometer. As long as the radiation comes here from this eyepiece side, human will stand and that observer will observing the filament of the lamp. When the filament brightness and temperature hot body brightness both are equal, the filament will disappear. That is the status. At that time, what is the current flowing through the rheostat? That will be indication of the temperature. That's about the temperature measurement. Next, we have discussed about the radiation pyrometers. In the radiation pyrometers, we'll take the radiation from the lens and the mirror, and that radiation will be focused onto the detector, and that will be displayed on the focused onto the detector. That will be measured by the detectors. Those are thermopiles, thermobolometers, and photovoltaic multipliers, like that. By using those devices, we can measure the temperatures. are the advantages of these particular devices? Those are nothing but ability to measure high temperature, no need for contact, fast response speed, high output, moderate cost. Disadvantages: emissivity errors are introduced, errors due to the absorption of radiation by carbon dioxide, water, or other apparently transparent gases. Common detectors: thermopiles, photocells, metal bolometer, thermistor. We also discussed infrared pyrometer. Whatever the body that is generating infrared radiation, that is called as the target, that is emit IR radiation that will flow in through the atmosphere, and here we will be having a detector. That detector will absorb the IR radiation and that will be displayed in the interface. IR radiation, that is, here is the IR indicator. What are the advantages of IR radiation? IR radiation pyrometers: high temperature measurement, wide range, fast response, measuring moving object, measuring objects which are difficult to access. IR detectors. Next, what are the different level measuring devices? Level measurement in steel plant by using eddy current transducer. Here we will be having a eddy current sensor, level monitoring or level measuring sensor. Here the sensor will consisting of primary coil and a detecting coil. This primary coil it it the voltage or current will be applied to the primary coil with some frequency. Because of that, the magnetic field will be generated, that will be linked with the molten metal. Then eddy currents will be produced. Because of that eddy currents, the field will be introduced into the detecting coil. The detecting coil currents will be produced in detecting coil, that will be passed through the positive feedback amplifier, and it will be given as input to the signal processing amplifier, which will give a level signal to the level controller, or which will give a level signal to the mold level controller, which this mold level controller will move the servo amplifier, it will move the actuator, then the flow or level will be controlled. This is about the eddy current level measuring unit, level measuring sensor, which can be used in the steel plant. This is about the different parameters measurement in the iron and steel plant. We have discussed about lot of parameters. In the industry, we will be using lot of parameters measurement like density, thickness, weight, pressure, viscosity, like that. But among those, in case of iron and steel plant, temperature is very important. So that's why our primary importance is to the temperature. So mostly in the iron and steel plant, we will be giving importance to the pyrometers, because here we are dealing with large temperatures, because iron will be formed at 1700 degrees centigrade. So at the 1700 degrees centigrade, we have to measure such a large or big temperatures. That's why we are dealing with the pyrometers in the industry. In these pyrometers, we will deal with optical pyrometers or IR pyrometers, or we can go for the digital pyrometers and radiation pyro. Mostly we will discuss with the radiation pyrometers, which are the output will be in digital format. So digital radiation pyrometer will be used in the iron and steel plant. Next, we have discussed about the Molten steel level measuring using eddy current level meter. This is a very important measuring transducer or eddy current transducer which can be used in the iron and steel plant. Thank you. Next, in the next class, we will discuss about thickness measurement and weight and thickness measurement and density measurement in the next class. Thank you.